Hi everyone, in this video lecture we are going to learn about Bode plot. This is also one plot which is used to determine the uh, design and analysis purpose of the control system. So basis of Bode plot. So main function of Bode plot is it is a graphical method which is used to design and analyze the control system. In a Bode plot, logarithmic scale is used. It helps in simplifying the way to graphically represent the frequency response of the system. So in this Bode plot, we are having two important plots. One is magnitude plot and the other one is phase plot. So the magnitude plot is the one which is used to determine the magnitude of the system, and the phase plot is used to determine the phase of the system. Both plots, x-axis and y-axis are x-axis and y-axis are considered, and in x-axis the frequency is noted in logarithmic scale, whereas in y-axis the magnitude is considered in considered. So magnitude m is determined as m is equal to 20 log g of omega into h of omega, and phase angle phi is determined by phi. Phi is calculated as phi is equal to angle of g of j omega into h of j omega. So in this plot, magnitude is represented in logarithmic values against logarithmic values of frequencies, and transfer function g of j omega and h of j omega in order to express the magnitude in logarithmic values, and the magnitude in decibel is plotted for 10 log omega. So this is graph is called as magnitude graph. So that is m equal to 20 log k decibels for angle phi equal to 0 degrees, k equal to 1 is then magnitude is 0 dB. K is greater than 1 means the magnitude will be positive, and k is less than 1 means the magnitude will be negative. Bode plot is also called as the logarithmic plot, and it is sketched on the logarithmic scale. Main function of this Bode plot is used to calculate the gain margin and phase margin of the system. Let us note one example. So it is given as g of s is like this, and first we have to calculate this one in standard form. Standard form is in terms of s into 1 plus. So it is written in standard form. After writing the standard form, replace this s by j omega, replacing all the s by j omega. This function will be like this. So here consider 0 plus j omega, and second term 1 plus j3 omega, third one 1 plus j4 omega. Now calculating the corner frequencies omega c1 and omega c2. So it will be 1 by 4 here and 1 by 3 here. So 1 by 4 plus 1 by 3, that is 0.25 and 0.33. So arranging the center frequencies and finding the slope in decibel per decade and change in slope. So first function is 20 divided by 0 plus j omega, and second one is 1 plus j4 omega, and third one is 1 plus j3 omega. So we have to arrange this one according to the corner frequencies in the order. So first corner frequency is no real part term, and second one is lesser corner frequency term, and third one is greater corner frequency term. 0 plus j omega means there is no real term, so here the slope is minus 20. 1 plus j4 omega, so the slope varies from again minus 20, and 1 plus j3 omega again minus 20. That is overall slope is for second function is minus 40, third function is minus 60. Choosing omega c1 frequency and omega c2 frequencies in such a way that lesser one and is first omega c1, greater one is omega c2, and omega l and omega h is determined in such a way that that is a middle frequency in between these two ranges, and calculating another some values omega l, omega c1, omega h, omega c2 like this, and after finding this all values substituting and find A value is calculated as slope from omega c2 to omega c1 to omega c2 into log omega c2 divided by omega c1 into a omega c1. So first is a point is determined, then we have to determine for omega h this value, this same thing, substituting the same things and calculate second value, that is a equal to 4 dB. And similarly for phase plot we have to consider the phase angle, that is changed from phase angle phi equal to minus 90 degree. For j omega it is minus 90 degree, and 1 plus j3 omega it is minus tan inverse 3 omega, similarly minus tan inverse 4 omega. Also this tabular column represents all the points plotted in this to be plotted in the phase plot and the magnitude plot by using calculator and finding all those values. And after finding this tabular column we have to plot this one. This is called as magnitude plot, and this straight line is called as phase plot. So calculating this magnitude plot and phase plot, this crossover frequency is calculated. So gain crossover frequency, see this one, this frequency is gain crossover frequency. You just extend this gain, and this intersecting point of this one in x-axis is called as gain crossover frequency. Here it is calculated as 1.2 radians per second. Similarly all these points are calculated. So it is having the magnitude of 0 dB up to omega equal to 1 by tau radians per second. This is called as asymptotic Bode plot. So it is used for analyzing the characteristics of control system. Thank you.